Welcome everyone to this presentation on the fundamentals of JavaScript. JavaScript is the backbone of web development, powering the interactivity and dynamic behavior of websites and web applications. In this session, we'll dive deep into the core concepts that form the foundation of JavaScript, from data types to functions and beyond. By the end, you'll have a strong grasp of the essential building blocks that will enable you to start building your own web projects with JavaScript. Let's get started. JavaScript has 7 primitive data types: string, number, boolean, null, undefined, symbol, and big int. Primitive types are immutable and represent a single value. Strings are used for text, enclosed in single, double, or backtick quotes. Numbers represent integers and floating point values, with no separate int or float types. Booleans represent logical true or false values. Null represents an intentional absence of value. Undefined represents a variable that has been declared but not assigned a value. Symbols are unique and immutable identifiers, useful for creating private object keys. Big ints represent large integers beyond the safe range of the number type. Objects are the most commonly used complex data type, representing collections of key-value pairs. Objects can contain any value, including primitives, arrays, functions, and other objects. The summary table provides a quick overview of the different data types and their characteristics. JavaScript has 7 primitive data types: string, number, boolean, null, undefined, symbol, and big int. Strings are text, enclosed in single, double, or backticks. Numbers are all 64-bit floating point, including integers. Booleans are true or false. Null represents an intentional empty value. Undefined means a variable has been declared but not assigned a value. Symbols are unique, immutable identifiers. Big ints are for representing large integers beyond the normal number range. Primitives are immutable. Their values cannot be changed once created. Operators are the fundamental building blocks that allow us to create dynamic and interactive JavaScript programs. We'll be covering the 4 main types of operators: arithmetic, assignment, comparison, and logical. Arithmetic operators like plus, dash, asterisk, /% enable us to perform basic mathematical calculations in our code. Assignment operators like equals, plus equals, dash equals allow us to assign and modify values stored in variables. Comparison operators like equals equals, equals 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 help us check the relationships and equality between different values. Logical operators like and combine multiple conditions together to create complex logical expressions. We'll look at examples of each operator type to see how they can be used to control the flow and behavior of our applications. Understanding how to effectively leverage these operators is key to writing powerful and expressive JavaScript code. JavaScript has a variety of operators that allow us to perform different types of operations on values. The first set are the arithmetic operators, which let us do basic math like addition, subtraction, multiplication, division, and finding the remainder. These are straightforward operations that you're likely familiar with from math class. Next, we have the assignment operators, which allow us to assign values to variables and update those values. The basic assignment operator is just the equals sign, equal symbol, but we also have shorthand versions like plus equals and asterisk equals, which combine the assignment with an arithmetic operation. For example, x plus equals 5 is the same as saying x equals x plus 5. These operators make it easy to update variable values in a concise way. Comparison operators allow us to compare values and types in JavaScript. The equals equals operator checks for loose equality, where only the values are compared, not the types. The equals 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 operator checks for strict equality, where both the values and types must match. The equals operator checks for loose inequality, where only the values are compared. The equals equals operator checks for strict inequality, where both the values and types must not match. Logical operators like and allow us to combine or negate conditions. The summary table provides a helpful overview of the different operator types in JavaScript and their purposes. The slide introduces the concept of conditional statements in programming, specifically the if/else structure. It explains that the if statement executes code if a condition is true, while the else statement provides an alternative path if the condition is false. The slide includes a simple JavaScript example that checks the user's login status and logs a welcome message if they are logged in, or a prompt to log in if they are not. The key points are the purpose of conditional statements, the structure of if/else, and how they can be used to make decisions in code. I'll walk through the example to illustrate how if/else statements work in practice. The key steps in a loop are initialize, check condition, execute code, and update. Initializing sets up the starting point for the loop. Checking the condition determines if the loop should continue. Executing the code block runs the commands inside the loop. Updating modifies variables so the loop progresses to the next iteration. For loops are ideal when you know the number of iterations ahead of time, while loops repeat until a certain condition is met. Here's some example code to illustrate how for and while loops work. Functions are reusable blocks of code that can take inputs and return outputs. This promotes modularity and reduces code duplication. We can define a function once and call it multiple times. Let's look at a couple examples. The greet function takes a name parameter and returns a greeting message. The add function takes two parameters a and b and returns their sum. Functions allow us to write code that is more organized, maintainable, and flexible. Arrays and objects are two fundamental ways to store collections of data in JavaScript. Arrays are ordered collections of values, accessed by numeric index. Objects are unordered collections of key-value pairs, accessed by property name. Arrays are great for lists, while objects are ideal for representing structured data like user profiles. Let's look at some code examples to see how these data structures work in practice. Arrays are ordered collections of values that we can access by their index, starting at 0. Here's an example of creating an array of fruits and accessing the elements. We can add new elements to the array using the .push method. Arrays are great for storing lists of things like tasks, names, or inventory items. The size of an array is dynamic. We can keep adding new elements as needed. Objects are unordered collections of named properties or key-value pairs. They are useful for storing structured data like information about a person. Here's an example of creating an object to represent a person, with properties like first name, last name, and age. We can access the properties using dot notation, like person.firstname, or bracket notation, like person first name. Objects are great when you need to associate data with specific names or identifiers, rather than just a list. The summary table compares some key differences between arrays and objects. Arrays are ordered and accessed by index, while objects are unordered and accessed by property name.